In this demo, I'll show how AppGlass helps diagnose how to reproduce production issues by attaching to a live application and inspecting real execution data. Let's start with the production report in the PetClinic application. A user adds a new visit for a pet. The visit is created successfully, but the user doesn't receive an email notification. First, I'll show the expected behavior. I log in as Betty, add a new visit, submit it, and everything works. The visit is created and the email notification is sent. Now I repeat the exact same steps as George. The visit is still created, but there's no email notification. To investigate this, I attach AppGlass directly to the running application. I open the AppGlass tool window, specify the host and port of the running service, and click Connect. I already know where the relevant code is, so I place a few live breakpoints around the visit creation and email logic. Now I run the same action twice, once for Betty and once for George. AppGlass automatically captures request identifiers for each execution. I group the breakpoint hits by request ID, similar to how observability tools group traces. When I compare the two requests, the difference is immediately visible. The working request hits all the breakpoints, including the email logic. The failing request never reaches the email sending code. Since the email code isn't executed at all, instead of exploring the code path manually, I'll use AI to generate the next set of breakpoints. I describe the problem and specify that we only want signals from George's flow. AI analyzes the code base and suggests a focused list of breakpoints across the validation and notification path. Each suggested breakpoint already includes a condition, so it only triggers for George. I open one of these breakpoints to show the condition. These breakpoint conditions are safe to use in production. AppGlass guarantees they don't cause side effects and finish quickly. If a condition is unsafe or too slow, it's rejected automatically. Now I run the same request for George again. After running the failing request, the execution is captured with these conditional breakpoints. AI automatically retrieves the collected trace once the problem is reproduced and uses it as runtime context for analysis. AI summarizes the key difference between the working and failing flows and points directly to the validation logic blocking the email notification. To confirm the observation with the real data, I open a snapshot captured in the validation logic and inspect the program state. From this snapshot, I can expand the owner object and see its fields directly. First name, last name, phone, and other values without adding logs or changing the code. Here, we can clearly see that George's phone field is invalid. Because of that, the validation fails, and the application skips the email sending logic. With AppGlass, we didn't need to export production data, add extra logs, or redeploy the application. Instead, we attached to a live system, used targeted breakpoints, both manual and AI-assisted, analyzed the real execution trace, and identified the root cause safely in production.